All right, so our next part of Module 101 is booting the system. So we'll look at some of the options that you have for telling the system how to boot and which kernel you'd like to use and things of that nature. You also would be expected to know what the boot sequence entails. There will definitely be questions on the exam asking about this. We'll look at System 5 init commands, which are more the legacy way of doing things compared to System D, which is the newer way of doing things. We'll also touch on the upstart utility. We'll look at boot events in various log files, and we see that we've got some commands here and some files and things that we'll be touching on as we get through this chapter. Now, Linux supports GRUB, which is the Grand Unified Bootloader. And it's kind of a nice little acronym. And what this means is that we've got the ability to have multiple kernels available for booting on a particular system. This is very useful because sometimes as an administrator, you're going to need to make changes to the kernel. And usually when that happens, what we want to do is build the new kernel and also retain the current kernel. This way, if we boot up in the new kernel and there's a problem or something's not right, we can always reboot from the previous kernel and go back and make some changes and try again. So this grub make config command is just a sample here showing once I make some changes to the default settings, I can generate a new config file and have that new kernel show up in my boot menu, which we'll see here in just a little bit. Now, when CentOS gets installed, first the system will do the inspection of the BIOS. We'll talk a little bit about the power on self-test. And if you were unsure about the compatibility of your system, you can always go to the CentOS hardware compatibility site. I'll bring this up really quick. And this is very handy to be able to determine if I want to use something like a graphics card. Well, which ones can I use? It's not showing much detail there. But it's trying to tell me of all the different versions of devices, how do I determine which ones are compatible with my intended hardware. And I can also specify how I want the kernel to be accessible. If you remember when we ran the dmessage command and one of the other commands, we saw some of the kernel parameters, like specifying where the root, where the root partition is located, or even specifying that it's read-only. So if my boot partition is read-only, that's a good thing because I boot the operating system from a read-only data. I don't have a chance to write to that partition, so it's less chance of any security problems or any data corruption. And I have various parameters which I can specify for the kernel to suit my various needs. The quiet option is nice because, as it says, I won't see any messages that are not considered critical, which minimizes the amount of information I see on the screen or in my log files. I can also define the buffer size for the kernel log. This might be important as far as limiting the buffer size in order to prevent the system from running out of space if it was built without a lot of consideration for growth. In the last section, we also saw mod probe, being able to see which kernel modules are currently loaded and being able to add and remove those as needed. And if my system crashes and the kernel dumps its contents contents of memory to disk, I want to be able to specify where that crashed kernel data should be located. So if I go back to my Linux machine, one of the first things I want to do is go to the Etsy default directory. And you'll notice I have a file here for grub. Now, Etsy default is just what it sounds like. The Etsy directory in general is for configuration files, but I can define a default config file for various different commands, like the grub configuration or adding a user, as we see. But let's look at some of these parameters really quick. First, we have our timeout. This is the amount of time in seconds that the boot menu will give you to make a choice. Either you wait the 5 seconds and it boots automatically, or within 5 seconds you interrupt the boot by clicking on the screen and moving one of the arrow keys to move the cursor up and down. We'll see that here in a little bit. I can also define where my output of my terminal goes to. The console is the default settings, so that's pretty typical. And my crash kernel. So I can tell it that underneath my my root volume, I'm going to configure an area for saving the memory when the system crashes. So a couple settings there to look at. Now what I just did here was did a cat command on proc/command line. This shows me what the command line looks like to generate this kernel. I can see that my root partition is attached to /dev/mapper CentOS root. It is read-only, and I can see that my crash kernel will automatically be generated. That's what the auto setting means in this case. Tells me that it's the quiet setting has been enabled, so I don't see anything from the kernel that's non-critical. And it's a little bit hard to tell because I'm gonna make the monitor full screen. And also specifies my language variable, showing me that I'm using English language in the UTF-8 character encoding format. So these are nice little details about my kernel that are only visible once I've booted up. And usually when you're, in my experience, when I'm changing the kernel, it's because you're trying to do something to modify the way the system allocates resources. Maybe you're tweaking memory settings or tweaking some of your storage settings, trying to get better performance overall. This also might relate to how memory is used. So a RAM disk is just what it sounds like. It's a portion of disk which can be used like memory when the system boots. So the RAM disk gets loaded by the Grand Unified Bootloader, grub, and it runs sbin init. And the scripts that are in this directory will look for various services that are required to start up the system, start up the various components, and each script in this directory will have some purpose for the system. Things like starting networking, starting the connection of the drivers to my hardware devices, and so on. All this is done in order to get ready to mount the root file system, which is known as /. Again, these things in blue are usually config files or paths or commands. Now, the root file system has to be mounted during boot because this is where all of my subsequent file systems will use as a reference point for their mount points. And of course, we have to get our operating system files from this area. The drivers that the operating system needs to talk to the hardware, things such as RAID controllers, host bus adapters, HBAs, SCSI devices. The operating system can't talk to those hardware devices until the driver is loaded. The driver is an intermediary software that allows the operating system to send commands to a hard disk or to a video display adapter or a network card and tell it to do something or ask it for information. So when the system goes through its boot process, one of the first things that happens is the power on self-test. We're all familiar with this when you turn on a computer, especially PC-based systems. You hear a beep typically, and you get a bunch of diagnostic information on the screen. And what this is intended to do is to do a quick check of all the different required hardware components to make sure that they're all working. I need a display, I need a keyboard, I probably need a mouse, I need storage, I need to have access to my BIOS. And that's what the Power On self-test does. It does a quick check of all those things, initializes all the hardware to get ready for the first stage of the boot. So the first stage for Grub is loaded from the master boot record. That's what the MBR stands for. This will get all the drivers for the file system loaded into memory so that they can be ready for the mount point to actually take place. And the first stage of Grub also gets ready to load the second stage. Now the second stage of Grub will actually look at the config file, and that command line that we saw, that's what actually gets inspected to determine which kernel is going to be loaded and some of the parameters like read-only or the quiet parameter to limit non-critical messages. The RAM disk gets loaded, and what this means is that some of the kernel has to be still loaded from the disk, so we need a RAM disk to have some temporary storage in the physical memory of the system in order to get ready for the actual kernel to be initialized. When the kernel is brought from the disk, it's in a compressed format, so it has to be decompressed, and then whatever command line arguments we saw in that previous example would now be applied to that kernel being loaded into memory. The read-only feature, the quiet feature, and so on. When the kernel loads, the operating system takes the device drivers and will initialize them so that they can run and go talk to all the bits of hardware, your video display adapter, network card, storage adapter, and so on. So init RAM FS, this is initializing the RAM file system. This portion that's loaded from the disk will now take care of the subsequent tasks of getting kernel modules that we saw when we did that mod probe command. All those will now be loaded, all the ones that are configured to be loaded anyway, will be loaded into memory, and then finally the root file system gets mounted. Once that happens, the sbin init script will be run, and the system will continue its boot process. So let's have a quick look. If we look in the sbin directory, there's quite a few things here. We'll talk about what these files are, or what some of these files are later. But we notice that the init program actually has a link to systemd, which will also compare to the previous version of more the legacy way of doing things for Linux systems or Unix systems. So init, again, if you were running System 5, that init process will now go load all the other components of the operating system. So init really is the first main process or program that runs when the system goes through the boot process. Now, if we compare System 5, whoops, hold on one second. If we compare the System 5 way of doing things with systemd, which is the newer way, we've got some nice comparisons to see how these things translate back and forth. So if you're more familiar with more legacy Unix systems or Linux systems, you might recognize a service command. I can start and stop and restart and reload a service. Or if I'm running in a more modern system, which is systemd based, I run system control, systemctl. Very similarly, I can start and stop and reload the same way. So I can run a status command in both cases, see if the service is running. Underneath the rc.d and init.d folder underneath etc, we can see all of the System 5 init commands. On a systemd environment like CentOS is, I can run this system control list unit files and say, show me all of the services that are available on this system, which I can start and stop with these script commands. So I can reference a service underneath this folder and tell it to start and stop, very similar to what using the service command or the system control command. I can also determine if a service is going to be started and stopped automatically when the system boots. Stopping automatically is kind of an understood no-brainer kind of default setting. But only certain services are going to be started automatically. I want to be very selective about that so I don't start more services than I need. And we'll talk about that a little bit more detail when we get into the security considerations and other sections. I can also determine which run levels the service will be operational. Certain services might only be needed at run level 3, for instance, and I don't need them at run level 4. So you can configure that in order to have a more customized approach to how your system is configured and what it does when it boots. Now, Upstart, as it says here, this is a replacement for init. Init was considered a little bit too inflexible. Another reason why systemd was a good replacement. And so the etc init tab and the init directory underneath etc probably doesn't have much information in it for a modern system. We can go take a quick look. So there's my init tab. And as it says, this is no longer used when you have systemd available. But some of these legacy files still exist, and you should know a little bit about it in case you're in a situation where, in case you're in a situation where you're working on an older system and you want to be able to do some work. Now, when the system boots, one of the things that we probably would be considering is where can we find different details about what happened during that boot. We've already looked at dmessage. This is the things that would go to the console. These are kernel-related messages. And we'll also look at the /var/log, boot log, and varlog messages. Generally for Linux systems, most of your logs are contained under /var/log. And that's a pretty typical convention and makes for a little bit of ease for finding information that events that you're interested in. So if I go to varlog, do a long listing here, we can see there's quite a few items. This is where all the logs are contained for various things that are going on with the system. There's dmessage. But I also want to look at the boot log. So boot log doesn't have anything in it, that's okay. If I look at messages, which is kind of a general purpose catch-all, messages has quite a bit of data. So I'm going through several screens here and you can see there's all kinds of details about boot information. And maybe I'm interested in trying to find something specific, so I can cat the messages file and I can pipe that to grep-i and look for the word error. Clear the screen and run that again. So I've got a few lines with some errors, not too many. I can also look for the word fail. Quite a few of those. Or maybe I'm interested in something more specific, like events that happen at a particular time, like 1439. So you can see how easy it is to use the grep command. All the items that get matched return and they show up in red. Very, very useful. Now these messages that we see related to boot, They don't look like much at this point because we're not troubleshooting. We're not looking for anything in particular. We're just trying to find where we might look. And as I've written here, generally speaking, things that indicate failure are often more interesting than things that indicate success. So these are some of the commands that we've investigated for this section. Make sure you do spend a little bit of time practicing with these. And that is the end of the booting the system module, or the section with this module. And then for our last bit, we're going to change run levels, boot targets, and shut down the system. All right, see you in the next section.